So today we're talking function notation. Function notation is another way of writing out functions, and it has a lot of advantages over the way that we kind of know how to do it before, which is something like this: y equals x plus 1, right? That looks familiar to us. Function notation would have us say f of x equals x plus 1. Notice it's called f of x, that's function notation. The reason function notation is useful is because that way we can talk about multiple functions at the same time. It's also useful in that it makes it so that if you have a couple of equations, you don't automatically think that they're equal to each other. F of x is the most common, however, you'll probably see g of x, h of x, or any other letter. I remember reading a paper in college where they had a Greek letter there. Another one you might see is d of t, where this represents distance, and this is time. Function notation, it's not too bad. A very common problem you'll see in function notation is they'll give you a function, something like, let's do a little bit more of a complicated one. We'll go h of x is x plus 1 over x minus 2. And then they'll tell you to find h of 10. I kind of just made up this problem. I pulled it out of a hat. It'd be the same as seeing it on a worksheet. So basically what you've got to do is everywhere that you see x in the original problem, you're going to replace that with 10. So it's going to be h of 10 is equal to 10 plus 1 over 10 minus 2. You can simplify and you'd get 11 over 8. You'd write your answer as h of 10 equals 11 over 8. All right. Note that f of x, like function notation, that f of x equals x plus 1 and y equals x plus 1 are very similar. And if I asked you to graph f of x equals x plus 1 and y equals x plus 1, it would graph identically. That's an important point. All right, the other thing that I just wanted to point out, we're going to talk just a little bit more, practice some domain and some range. Remember, domain is anything you can put into the function. All right, and range is all of the outputs. For most functions, the domain is going to be all real numbers. For example, f of x is equal to x plus 1. The domain for this is going to be all real numbers because, honestly, you can plug in any number, add 1 to it, and get a different number, and that works just fine. So you can go ahead and write it like that. And then the range, well, basically, if you just add one number to anything, you can just kind of subtract it for the range and find out that it's basically the same thing. That isn't always the case, though. For example, if we did g of x was equal to the absolute value of x, then the domain would be the same. You can plug anything into an absolute value. But think about absolute value. Once you take the absolute value of something, it's always going to be positive. So what's the smallest possible number you can get? In an absolute value? 0. And that can go all the way up to infinity. So 0 is included. We put the bracket on the other side. All right. The last thing we have to keep in mind is, let's go ahead and try h of x. right? So in this case, we can go ahead and plug in just about anything for the domain, any number we want. However, what happens if we plug in 2? H of 2. Well, we get 2 plus 1 over 2 minus 2. What's 2 minus? So that would be 3 over 0. Uh-oh, that's a problem. We can't do that. So that is undefined. Meaning in the domain, we have to tell it and say x cannot equal 0. I mean, not 0, 2. Because if it does, then we have an undefined function, and that's a huge problem for us. The range in this case, and once again, it's going to expand out. It's going to be all real numbers again. All right. Let me know if you have any questions.